Ever wondered why the moon looks so bright at night? Imagine if it suddenly disappeared. What impact would that have on Earth? Turns out, the moon isn't just a glowing ball in the sky. It plays a vital role in shaping our planet's rhythms and tides. Buckle up for our journey as we reveal the mysteries and significance of our lunar neighbor. Number 1. Moon's formation. The formation of the moon, known as the giant impact hypothesis, is a fascinating story in the early history of our solar system. About 4.5 billion years ago, during a period called the Late Heavy Bombardment, a Mars-sized celestial body, sometimes referred to as Theia, collided with the young Earth. The impact was incredibly violent, causing intense heat and energy. The collision led to a tremendous amount of debris being ejected into space, some of which coalesced to form a disk of molten rock and dust around Earth. Over time, gravity caused this material to gather and form the moon. The early moon was much closer to Earth than it is today, and it was likely molten due to the heat generated by the impact. As it gradually cooled, the surface solidified, forming the features we see today, such as craters, mountains, and plains. One of the pieces of evidence supporting the giant impact hypothesis is the similarity in isotopic compositions between Earth and moon rocks. Samples retrieved from the moon during the Apollo missions showed that they have remarkably similar chemical compositions to certain rocks found on Earth, suggesting a shared origin. This catastrophic collision not only contributed to the formation of the moon, but also played a significant role in shaping the early Earth, influencing its geological and environmental conditions, and possibly contributing essential elements necessary for life to develop on our planet. The study of the moon's formation provides valuable insights into the early processes that shaped our solar system. Number 2. Surface temperature extremes. The moon's lack of atmosphere greatly affects its surface temperatures, leading to dramatic temperature swings between day and night. During the lunar day, which lasts about 14 Earth days, temperatures can soar to around 127 degrees Celsius, 261 degrees Fahrenheit, or even higher in direct sunlight due to the absence of an atmosphere to filter out the sun's intense heat. Conversely, during the lunar night, which also spans about 14 Earth days, temperatures drop drastically because there's no atmosphere to retain heat. Without insulation, the surface rapidly loses heat, causing temperatures to plummet to approximately negative 173 degrees Celsius, negative 280 degrees Fahrenheit, or even lower in some shadowed areas. On Earth, our atmosphere acts as a blanket, trapping some of the sun's heat and redistributing it, which moderates temperature extremes between day and night. The lack of an atmosphere on the moon means there's no weather, no wind, and no protection from the sun's radiation or from the cold of space during the night. This extreme temperature difference makes it challenging for equipment and technology to function effectively on the lunar surface. Number 3. Moonquakes. Moonquakes are seismic activities that occur on the moon's surface, analogous to earthquakes on Earth, but with some differences in their causes and characteristics. These moonquakes were first discovered during the Apollo missions, and they've been identified as a result of various factors. Some moonquakes are caused by the gravitational forces exerted by Earth. The gravitational pull of Earth on the moon creates tidal forces, causing stress and tension in the moon's crust. These shallow moonquakes usually occur closer to the lunar surface. Other moonquakes are believed to be caused by the moon's cooling and contraction. As the moon's interior cools, it contracts, causing the crust to crack and shift, resulting in deeper moonquakes. These quakes can happen several hundred kilometers beneath the surface. Moonquakes can be categorized into different types based on their origins, duration, and intensity. Some moonquakes are relatively mild, while others can be more powerful, registering magnitudes on the Richter scale that would be felt by astronauts and potentially affect lunar structures. Unlike Earth, which has a dynamic tectonic system with moving plates, the Moon doesn't have active plate tectonics. Therefore, moonquakes are not caused by plate movements, but rather by these other factors related to the Moon's unique geology and interactions with Earth's gravitational pull. Number 4. Slow rotation. The Moon's rotation period and orbital period around the Earth are nearly synchronized, resulting in a phenomenon known as tidal locking. This synchronization means that the Moon rotates on its axis in about the same amount of time it takes to orbit the Earth, approximately 27.3 days. As a result of this synchronous rotation, we always see the same face of the Moon from Earth, a side known as the near side. The other side, which faces away from Earth, is often referred to as the far side or dark side, although it also receives sunlight. The term dark side is a bit misleading because both the near and far sides of the Moon experience day and night just like any other celestial body. However, the far side was historically unknown to humanity until spacecraft exploration provided the first images in the mid-20th century. Number 5. Lunar dust and footprints. The Moon's surface is covered by a layer of fine, powdery material known as lunar regolith. This regolith is composed of crushed rocks, soil, and dust created by constant meteoroid impacts over billions of years. Unlike Earth, where weathering and erosion gradually modify surface features, the Moon lacks significant geological processes like wind or water erosion, allowing the regolith to remain relatively unchanged. Apollo footprints and tire tracks. During the Apollo missions, Apollo 11 to 17, astronauts left distinctive footprints and tire tracks on the lunar surface. The lack of wind and water means that these imprints, made by astronauts' boots and the lunar rover's wheels, remain preserved. The disturbed regolith retains the shape of these footprints and tracks, creating a historical record of human activity on the Moon. Thank you for joining us on this space adventure. There's a universe of exploration ahead. Stay tuned and subscribe for new videos featuring Space 5.